Could a distant exoplanet hold the first signs of alien life? The James Webb Space Telescope has just revealed tantalizing clues about K2-18b that you won't believe. From an atmosphere that's got scientists buzzing to hints of hidden oceans, this could be the breakthrough we've been waiting for. Picture this. You're an astronaut, suited up and strapped into a cutting-edge spacecraft. Your mission isn't just another trip to the moon or even to Mars. It's far more audacious. You're headed to a distant exoplanet that's capturing the imagination of scientists and could hold the secrets to life beyond Earth. Welcome to the enigmatic world of K2-18b. Located in the constellation Leo, this planet is about 124 light-years away from Earth. That's over 730 trillion miles. A distance so vast it's hard to even wrap your mind around. But what makes this journey worth it is the planet's unique position in what's known as the Goldilocks zone. This is the orbital sweet spot where a planet is not too close to its star to be scorching hot and not too far to be freezing cold. It's just right for water to exist in liquid form. And as any biologist will tell you, water is often the first sign we look for potential life. But the intrigue doesn't stop there. K2-18b orbits a red dwarf star, one of the most common types of stars in our galaxy. These stars are not just long-lived, they can exist for up to 100 billion years. That's more than twice the current age of our Sun, giving planets like K2-18b an incredibly long window to potentially develop complex ecosystems. Just think about the kind of life forms that could evolve over such extended timescales. Guiding us on this journey through the stars is the James Webb Space Telescope, humanity's most advanced tool for exploring the far reaches of the universe. It's been capturing high-resolution data that's making even the most seasoned astronomers do a double-take. Imagine you're a detective, and you've just stumbled upon a locked room with a mystery inside. The only clue you have is a keyhole, and by peering through it, you can gather hints about what's hidden behind the door. In a similar way, scientists have been using the James Webb Space Telescope like a cosmic keyhole to peek into the atmosphere of K2-18b, and what they've found is nothing short of astonishing. The atmosphere of K2-18b is a cocktail of elements and compounds that has left researchers very excited. For starters, they've detected methane and carbon dioxide. And you might be thinking, so what? We have those on Earth too. But here's the kicker. The presence of these gases in the atmosphere of an exoplanet and the habitable zone is a tantalizing clue that life could exist there. Methane, for instance, can be produced by biological processes, and its presence, alongside carbon dioxide, could indicate a complex atmospheric chemistry. But it's not just about the gases themselves. It's also about their ratios and how they interact with other elements in the atmosphere. Scientists are using advanced spectroscopic techniques to analyze the light that passes through K2-18b's atmosphere. This allows them to identify not just what's there, but also how much of it exists, offering clues about the planet's climate, weather patterns, and even the possibility of liquid water clouds. So, circling back to our detective analogy, it's as if we've used our keyhole to not only identify objects in the room, but also to understand their significance and how they relate to one another. And just like the first set of clues in any detective novel, we're left with more questions than answers, fueling our curiosity and setting the stage for future investigations. Have you ever read a sci-fi novel where explorers stumble upon a planet so bizarre it defies all logic? What if I told you scientists are now talking about a new class of exoplanets that could be just as mind-bending? They're called Hycean worlds, and K2-18b might be one of these enigmatic places. What sets Hycean worlds apart? These are unique planets that are larger than Earth, but smaller than Neptune. They're characterized by hydrogen-rich atmospheres and the potential for oceans, not necessarily of liquid water, but possibly of other substances like methane. K2-18b is especially intriguing because it has a hydrogen-rich atmosphere and evidence of water vapor, making it a prime candidate for this new category of potentially habitable worlds. The excitement around Hycean worlds is their potential to harbor life. These aren't just barren hydrogen worlds, their unique conditions could be perfect for extremophiles, organisms that can live in extreme environments. Imagine a planet where life is adapted to high pressures, or varying chemical compositions in the oceans. The presence of methane and carbon dioxide in K2-18b's atmosphere adds another layer of intrigue, hinting at complex chemical processes that could be linked to life. So, circling back to that sci-fi novel scenario, the concept of Hycean worlds isn't just a flight of fancy. It's a scientific revelation that's expanding our understanding of where life could exist. Have you ever smelled the ocean and felt instantly connected to something vast and maybe mysterious? That salty, tangy scent might remind you of vacations and beach days. But did you know it's actually caused by a molecule called dimethyl sulfide? Now, what if I told you that this very molecule could be a game changer in our search for alien life if it's confirmed to be present on K2-18b? Dimethyl sulfide, or DMS, is a sulfur compound that's abundant in Earth's oceans. It's produced by plankton and plays a crucial role in various ecological processes. But here's where it gets wild. Scientists suspect that DMS might be in the atmosphere of K2-18b. That's right, the same molecule that gives our oceans their characteristic smell could be potentially floating around in the atmosphere of a distant exoplanet. Why is this a big deal? On Earth, DMS is linked to biological processes. If it's confirmed to be in K2-18b's atmosphere, it could be a tantalizing hint that similar biological processes are at work there. It's like finding a fingerprint at a crime scene. It doesn't prove anything definitively, but it's a clue that's hard to ignore. Moreover, DMS plays a role in cloud formation on Earth. If it's doing the same on K2-18b, it could have implications for the planet's climate and even its potential to support life. Imagine clouds of DMS helping to regulate temperature on an alien world, creating conditions that could be just right for life. Let's come back to that first whiff of ocean air. The next time you're near the sea, breathing in that salty aroma, consider how that familiar scent could be the key to unlocking mysteries in far-off worlds. Next, think back to the first time you looked up at the night sky and wondered if someone, or something, was looking back. That sense of wonder has fueled humanity's quest to find life beyond Earth. So where do we go from here, especially with all these tantalizing clues from K2-18b? The James Webb Space Telescope has been a game changer in gathering data on K2-18b, but it's not the only player in the field. Missions like TESS, which was launched in 2018, and the European Space Agency's Plato mission are also contributing to exoplanet research. These missions aim to find more Earth-like planets in the habitable zone, and who knows, maybe even detect direct signs of life. But it's not just about finding new planets, it's also about studying them in greater detail. Advanced spectroscopy techniques are in development to analyze the atmospheres of these distant worlds more precisely. The goal? To identify biosignatures, or signs of life, in the atmosphere. Imagine the day when we can finally say, we found it. Undeniable proof of life beyond Earth. And let's not overlook the role of artificial intelligence and machine learning. These technologies are helping scientists sift through massive amounts of data, identifying patterns and anomalies that the human eye might miss. It's like having a super smart detective on our investigation team. So, as we circle back to that childhood moment of gazing at the stars, know that the search for alien life is ramping up in ways we could only dream of back then. Remember the famous WOW signal picked up by the Big Ear radio telescope back in 1977? The signal lasted for 72 seconds, but the speculation and excitement about its potential significance have reverberated for decades. That electrifying moment encapsulates the excitement and mystery surrounding our quest to find life beyond Earth. So what are the burning questions keeping today's astronomers on the edge of their seats, especially when it comes to K2-18b? First up, could this planet host its own unique forms of plants and animals? While we don't have concrete answers, the planet's atmospheric conditions are a hotbed for scientific speculation. With a mix of methane and carbon dioxide, along with water vapor, the atmosphere could potentially support some form of life. With researchers hot on the trail and new missions coming up soon, we may just have a groundbreaking discovery in the not-too-distant future. Next, let's tackle the question, what would it take for humans to actually visit K2-18b? The planet is a staggering 124 light-years away. Even with our fastest spacecraft, like the Parker Solar Probe, which travels at about 430,000 miles an hour, it would take thousands of years to get there. But don't lose hope. Projects like the Breakthrough Starshot initiative aim to develop spacecraft that can travel at a significant fraction of the speed of light. That said, these technologies are pretty far away from being able to carry humans into space, at least for today. Next, let's dive into some of the more speculative theories. One captivating idea is that life on K2-18b could be silicon-based instead of carbon-based. This isn't just science fiction. Researchers are considering alternative biochemistries as they broaden their search criteria for extraterrestrial life. Silicon-based life could potentially survive in more extreme conditions, expanding the types of planets we consider habitable. So, circling back to the wow signal, that moment of excitement serves as a lasting reminder of the endless possibilities that await us. Your curiosity, your questions, they're the modern-day wow signals, driving us to explore further and dig deeper into the universe's great mysteries. If today's deep dive into K2-18b and the search for alien life has you hooked, you won't want to miss our video all about the James Webb Space Telescope, the eye in the sky that's making all these discoveries possible. Click the video on your screen now to get the full scoop. And trust me, it's a journey worth taking. As always, thank you for watching, and I'll see you next time.